Good evening and welcome to the Q&A session 5 from the chapter of Nuclei. The topic is the calculation of rate of decay of a radioactive substance, and this session is in continuation of the session number 4 in which we have studied about the law of radioactivity. So the question for this session is the count rate of the emitted particles from a radioactive substance at t equal to 2 seconds is 1600 counts per second and 200 counts per second at t is equal to 8 seconds. So the count rate at t is equal to 6 seconds is, so यहाँ पे चार options हैं हमारे पास में और we have to find the correct option. So in the previous session we have studied that the rate of decay of a radioactive substance, that is dN upon dt, is equal to minus lambda n, where n is the number of radioactive nuclei which is present at any moment of time. And there was one more relation, that is n is equal to n naught multiplied by e to the power minus lambda t. Here lambda is the decay constant. So, and n naught is what? It is the number of radioactive nuclei present at t is equal to 0. So, if I combine both these two equations, I will get the rate of decay of the radioactive substance as minus lambda. Now, n is equal to n naught multiplied by e to the power minus lambda t. So, this is equal to minus lambda n naught e to the power minus lambda t. So, this is the equation which I will be using in this question in order to find the count rate at t is equal to 6 seconds. So, let us take the first case, that is at t is equal to 2 seconds, the count rate of the emitted particle is equal to 1600 counts per second. So, dN upon dt is equal to 1600. This is equal to minus lambda n naught multiplied by e to the power minus lambda t. Now, t is equal to 2. So, this is equal to minus 2 lambda. And from the second case, I will be getting 200 is equal to minus lambda n naught multiplied by e to the power minus, here t is equal to 8 seconds, so this is equal to minus 8 lambda. So this is the first equation and this is the second equation. Now if I divide the equation number 1 by 2, then I will get 8 is equal to e to the power, this will this lambda and n naught will get cancelled out, and I will be getting e to the power minus 2 lambda divided by e to the power minus 8 lambda. So finally I will be getting e to the power 6 lambda. So this is the relation which I have got, that is e to the power 6 lambda is equal to 8. Now, we have to find the count rate at t is equal to 6 seconds. So, dN upon dt, that is the rate of decay of this radioactive substance at t is equal to 6 seconds, will be equal to minus lambda n naught multiplied by e to the power. Now, here t is equal to 6, so this is equal to minus 6 lambda. Or simply this can be written as minus lambda n naught upon e to the power 6 lambda. Now, e to the power 6 lambda is equal to 8. So, now I have to only find the value of lambda n naught, and if I am able to find this value, I will be getting the count rate at t is equal to 6 seconds. So, what I will be doing is, from the first case, that is at t is equal to 2 seconds, the count rate is 1600 counts per second. So, 1600 is equal to minus lambda naught minus lambda n naught multiplied by e to the power minus 2 lambda. So from here, minus lambda n naught, this is equal to 1600 multiplied by e to the power 2 lambda. Now here this 8 is equal to e to the power 6 lambda, so this can be written as e to the power 2 lambda to the power 3. or we can say that 2 to the power 3 is equal to e to the power 2 lambda to the power 3. So from here we can see that the value of e to the power 2 lambda, this is equal to e to the power 2 lambda is equal to 2. And minus lambda n naught will be equal to 1600 multiplied by 2. So this is equal to 3200. So the value of the count rate at t is equal to 6 seconds, that is, this is the rate of decay of the radioactive substance, or we can say it is the count rate at t is equal to 6 seconds. This is equal to minus lambda n into 6 to the e to the power minus 6 lambda, or this is equal to minus lambda n naught divided by 8. So minus lambda n naught is equal to 3200. So 3200 divided by 8. This is equal to 400 counts per second. So here the correct option is C. So thank you very much for joining this session. In the next session, we will be continuing with the same topic of the law of radioactivity, and we will try to solve some other different type of questions based from the topic of law of radioactivity. So till then, have a nice day. Bye.